Hello, you're welcome. Okay, so now in this tutorial, we're going to be looking at linear motion, all right? Okay, so now linear motion is actually one topic in mechanics that deals with the motion of an object, okay, in a straight line. Now, there are different motion, okay, that an object can exhibit. Example, we have the translational motion, which is the same thing as linear motion, okay? Now, this is a motion of an object in a straight line. For example, you have a car moving in a straight line, all right? Then, of course, we have other type of motion, which of course includes circular, all right? Circular motion. We have rotational motion, we have random motion, we have simple harmonic motion. But here we are only looking at linear motion, all right? So linear motion is the motion of an object in a straight line, all right? Now let's look at the terms which, of course, you're going to be using in this tutorial, okay, to describe linear motion. Now, the very first term that you use, especially when it has to do with motion, okay, of an object, is the speed of that object. Now, what is speed? Now, speed of an object is defined as the rate at which distance changes, okay? The rate of change in distance. And mathematically, this is how you write the formula for speed. So speed is change in distance all over time. So now, in a simple term, okay, speed is just talking about how fast an object moves, okay? So how fast an object moves depends on the distance it changes in a unit time, okay? The distance it can change per unit time. And of course, that is why the SI unit of speed is actually given as meter per second, so right? Because the SI unit of distance is meter and the SI unit of time is seconds. So the SI unit of speed is meter per second. This is how you write it. All right, so now let's proceed. We'll have velocity. Now, velocity is the change in displacement, okay, with time. The change in displacement divided by the change in time. All right, now the SI unit of velocity is still meter per second. Why? Because the SI unit of displacement is meter, then the SI unit of time is seconds. So that's why we have the SI unit of velocity being meter per second. All right, but now the question now is velocity and speed is having the same SI unit, meter per second. All right, so what's the difference? Now the difference between the two is that for velocity, all right, okay, for velocity, as you can see here, speed and velocity, they have the same SI unit, okay? The difference between them is speed is a scalar quantity having only magnitude, okay? While velocity is a vector quantity having both magnitude and direction, right? So that is, they are the same, but just that one has direction, which is, of course, is velocity, right? Velocity has direction. Why? Because velocity is expressed in displacement. Displacement, okay, is distance in a specified direction, okay? So now, apart from the introduction of direction, apart from the direction that is also a means of expressing velocity, okay, speed and velocity actually they describe the same thing. So now we are not actually talking about vector quantity here. We are this linear motion, we are only looking at scalar quantity. So that simply means that speed, okay, in this particular topic, speed and velocity will refer to the same thing. So anytime you see me using speed, I'm equally talking about velocity, okay? So they are not different here, right? So let's proceed. I'll be taking the notes, okay, and I'll be pasting on the screen, then we'll describe it, and we'll be going forward like that, okay? So now let's proceed. We are going to look at a very important part, of course, of this tutorial. Now, the important aspect of linear motion, okay, which is very, very relevant when it comes to examination, is the part that has to do with okay, solving question, okay, based on uh, linear motion, right? So, and of course, that is where students always have issues. How do we actually evaluate question using the equation of motion? So that's what I'm going to illustrate here, okay? Now, to solve any question on linear motion successfully, we will apply the equations of linear motion. Okay, now the equation, I have actually summarized the three equation, and please, all you need for linear motion is actually embedded in three equation. Okay, though when you look at some book, they'll give you four. Okay, four is a simply an intermediary. The second, okay, if I might say, is actually an intermediary to this second equation I have here. So everything you need. So, and of course I have to simplify the formula so that the lesser the formula that you know, the more you can always remember it. Okay, so here we have the three equation. Now I'm going to actually use a different video, okay, tutorial to probably teach you how this three equation is being derived. But now we are only concentrating on applying this three equation, okay, because that is what matters. How do you apply? In case you know the three equations of linear motion and you don't know how to apply them, because that's what matters. How can you apply them? How can you use it to solve question? All right, so here they are. So these are the three equations of linear motion, and of course the first equation here is given as v equal to u plus at. Okay, all right, the second equation is given as s equal to ut plus half at square. You just need to write them down. You need to remember them, okay, offhand. Okay, you have the third one, v square equal to u square plus 2as. All right, so now the question now is what is the meaning of the parameters? All right, now v, of course, in a linear motion represent the final velocity. All right, final velocity, which simply means that an object has two velocity. Okay, any other time an object start to move, it doesn't start with the highest speed. There's always a starting speed and there's always a final speed. Okay, so there's u, which of course is the initial speed or velocity. Please take note of that. U is initial speed, while v is what? The final speed or velocity. All right, then we have the t, which of course you know should represent time, right? T represents time, and of course a represent acceleration of that particular object. Acceleration. Okay, and we have the last but not the least, x, right? Now s is not seconds, for in as much as equation of motion is concerned, we use s to represent distance. Okay, not d. Okay, we use s to represent distance covered. All right, so please take note of this, of these three equations. All right, so now let's bring the next node. Okay, so now we're gonna look at what you need to know, okay, before you can actually solve successfully question that actually involves linear motion. Now let's get something on the board. Right here we are. Now, in order for you to solve questions successfully in linear motion, okay, the following should be noted. Okay, so this is the thing that students need to acknowledge. Okay, if you actually having difficulties in solving question, okay, this should be acknowledged. Now, one of the things you should acknowledge is that every moving object will always start from rest and end in rest. Yes, that actually makes sense. Okay, now whether you started considering that object from moving from somewhere before that motion occur, something have actually need to cause that motion to happen. There's a man known as Newton. He stated Newton first law of motion. It said that, okay, every object will continue to be at rest or in a state of uniform motion unless it's being acted upon by an external force. So we simply mean that if an object is moving, okay, something must have actually caused it to move. So that object probably was initially at rest. So we can say that every object will always start from rest and end in rest. Okay. Now, if this object is actually, if you are considering the fact that the object is starting from rest, okay, the motion is starting from rest, please take note. In your calculation, you should know that your initial velocity, you should always equate it to be zero. Okay. From rest, initial velocity of every object is equal to zero. Okay. Now, if this object is moving already, then it comes to rest. The final velocity is equal to what? Zero. Okay. And the speed of the object must reduce, which simply means that if an object is coming to a stop, all right, it will start slowing down. Do you understand? The speed will reduce. Slowing down process in linear motion is what is known as deceleration. Why? Because it is negative acceleration. Deceleration and acceleration, they are the same, but just their opposite. Okay. Why acceleration is speeding up when object is actually speeding up, all right? When object is coming to rest, is slowing down. That is deceleration, okay, before it comes to rest. And at the point where it comes to rest, the final velocity at that point is equal to zero. So please take note of that as we apply this now in this question. All right, so I'm gonna shift this so that we have space. All right, example 2.1. All right, it goes like this: an object starts from rest and accelerates uniformly with a velocity of 20 meters per second. So if I should solve its solution, all I just need to do is to equate the rest. Okay, now please let me give you a very wonderful hint, especially when you are dealing with calculation in physics. Okay, now if you are finding it difficult to solve question in physics mathematical question comes in form of a word problems. Okay, it's not like a direct mathematical simplification where you need to just solve. That means that question will be given in a word problem. You will be the one that have to translate the question into a mathematical equation or formula before you can solve it. So most of the times what you do, okay, because you don't just start solving, you must know the formula to apply. All right, like now in this particular excuse me, like now in this particular topic, which is linear motion, that we have three equation of motion. Okay, now you are not using this three equation of motion at the same time. You're just gonna use one. Okay, so now the question is, which one do you use? The one you use depend on what the question gives. Are you okay? So that is why you read the question, the first thing you do is to write down the parameters. So when you read, whatever you see from the word problem, you write it as a mathematical parameter. So now I have seen that this object starts from rest. I know that from rest u is equal to 0. I gotta write it down. Okay, now and accelerate uniformly with a velocity of, so this velocity now becomes the final velocity, and of course v equal to 20 meters per second. All right, okay, that being the case, so now now we are not asked for, we are asked to find the distance we cover in what, in 5 seconds. So that means the time is 5 seconds. Okay, so the distance it covers. Now if I should actually excuse me, get to evaluate the distance, okay, I will ask myself, which equation of motion do I use that has all these parameters? Okay, now you discover that the equation of motion that actually fits these parameters for you to find distance, because you're looking for distance, is the second equation, which goes like this: s is equal to ut, right, plus half at square. All right, so now half at square. So having known that, all right, so we actually ask ourselves, how do we go about this? Okay, u is given, v is not here in this equation. T is not. So what is missing? I have A. A is not in this equation. So I need to actually get A. All right, since it's not given in the parameter. And of course, I can actually find A from the first equation, right? From the first equation, excuse me, from the first equation. Okay, let's go. From the first equation, you know that V is equal to U plus AT, right? So let me see if I have to put this value here, I have V is equal to 0, right? Then V is equal to 20. All right, U is 0. Then plus A, that's what I'm looking for, times T 5. Okay, for the first equation I will now have to get my A. So having this 5 times A will give me 5A, right? 5A plus 0 is T5A, then it's equal to 20. Okay, so which simply means that for me to get in A, it will be equal to 20 all over 5, which of course A is equal to 4 meters per second square. And of course that was the only thing that was missing for me to solve that equation. So having gotten my acceleration, I can now apply the formula of the distance to get my distance. Okay, so I got my A, I have to put it inside here. So invariably now I can now simply say that, okay, my x is going to be equal to U, of course, 0, that's initial velocity, okay, times the time, that's 5 seconds, plus half A, which of course I've calculated to before, then T square. All right, T square, that's 5 square, right? Okay, so S is going to be equal to 0 times 5 is 0, so this is gone. So I'm left with this. Half of 4 is 2. So 5 square, we know is 25, right? So 5 times 20, 2 times 25 will give me 50. All right, so that is 50 meters. Is the answer to this. I hope that is well understood. Okay, don't worry, we'll get more questions. All right, so I will get this out. Okay, so let's see if we get more examples. Okay, moving forward. Okay, so example 2 hyphen 2. Let's bring it up. Okay, so here we are. Now we look at the question. A car moving with a velocity of 20 meters per second. So this car is already having initial velocity. That's what it means. It's not starting from rest. It's already having initial velocity of 20 meters per second. So I write it down. Was brought to a stop. Okay, so it was brought to rest. Remember what happens when an object comes to rest. The final velocity is equal to 0. After covering a distance of 20 meters, so the distance you cover x, that's the symbol, is 20 meters, right? All right. So it's evaluate the deceleration. Of course, what we need to evaluate at this point is the deceleration, which of course has a symbol A. Okay. Both acceleration and deceleration are the same. Okay, just that one is opposite the other. Since this object is coming to a rest, what we have to evaluate is the deceleration. So now see the parameters U, V, S, and A. Which equation captures these 4 parameters? You discover the equation that captures these 4 parameters is the third equation, which is V square, right? Equal to U square plus 2AX. Okay, so you use the equation that best capture the 4 parameters. So putting the values of V there, so I'm gonna have 0 square, right, equal to U, that's 20 square, right? Then because of this, the object is coming to rest. The A I'm looking for is deceleration. So this plus will change to minus. Why? Because AB minus times plus will still give me minus. So this will change to minus. So please take note of that. Or better still, let me come here and put that. Okay, so minus A. Please take note of that. Of course, times the distance, which is 20 meters. Okay, so it's gonna be 0. Okay, 20 square is 400. Okay, plus times minus is minus. Okay, so that's minus 2 times 20 times a. So 2 times 20 is 40. All right, then 40 times a, that's 48. Take the minus 48 to this other side, it becomes plus 48. So I have 40a, all right, equal to 400. Oh, yeah. So what do we do? So to get our a, we divide. So that's going to be 400 all over 40. Here we go. We divide that, and of course our answer is going to be 10. 40 divided by 4, 10 meter. And of the SI unit of acceleration is meter per second square, right? So it's as simple as that. Just know how to apply the formula, you're good to go. Let's see if we have or we proceed. Okay, if there's another question, we work on it. If there's no, we proceed. But later we'll just get a lot of question to work with. All right. Okay, so I see another question here. Then I'm gonna do justice to it. Here we go. I bring it to my screen. Okay. First, this goes like this. What during the training session, two footballers pass ball repeatedly between themselves. Give two reasons why this to and fro motion of the ball is a simple harmonic motion. All right. Okay. So this is a footballer here. Is here. This one is here, and their feet at that same point. They are not moving. Okay. This one passes a ball. The ball reaches this one leg and comes back. Okay. To and fro. Okay. So it's a simple harmonic motion because the ball is actually moving to and fro. Simple harmonic motion is a to and fro motion about a fixed position. So this point, these two person actually create a fixed position for this ball to move to and fro. So that is the answer. So it is simple harmonic motion because of the to and fro movement of the ball, right? So please take note of that. Take note of that. Let's see. Got another question to work on. All right, I think we have. I bring it up. Okay. And better still. Okay, so let's see. Okay, I'm looking at a question that will describe what we've already learned. Okay. All right, so we'll get more question. All right, we'll get more question, but let's move straight to the next subtopic. Now we just set a video aside, okay, that we will use to solve a whole lot of questions. So I bring another subtopic. Okay, so here we are. All right, so motion under the influence of gravity. That's what we are going to be talking about now. Motion under gravity. When an object is said to be under the influence of gravity, okay, it means that that object is moving vertically upward or downward. Is thrown up or down. All right. You know very well that you can never jump up and still remain in the air. Why? Because there seems to be a force that pull you down, and that force is actually a force of gravity, right? All right. So that is why a man known as Newton actually said that everything that goes up must surely come down, unless there's a force that keeps that particular object afloat. Okay, so and if the force, if an object remains afloat, okay, in the air without coming down, that means there's a force that have actually that force have actually create a kind of contradiction to the force of gravity. Okay, so and that's how aircraft actually works. Okay, um, aircraft actually has a mechanism in its engine that would displace air. Okay, that is actually good, large enough to carry the aircraft afloat, okay, against the law of gravity. So there's a mechanism. Without that mechanism, that will, okay, that will overcome the force of gravity, every object that is actually thrown up, okay, if there's no force that keeps it afloat, it will return back to the ground. All right, so now we are looking at the motion under the influence of gravity. Now I'm going to actually talk about it, okay, using the view of the man known as Newton, Isaac Newton. All right, now according to Isaac Newton, he's actually said that though he stated that every object that goes up will always come down. Okay, now he also said that anytime an object is under the influence of gravity, all right, anytime an object is under the influence of gravity, I think I got the note here so that you'll be looking at uh, uh, okay, so excuse me. Okay, all right, I think I've gotten what I'm looking for. All right, so here we go. I'll paste it. Okay, so now this is a continuation of this. Now, according to Isaac Newton, any object that is under the influence of gravity will have a constant acceleration due to gravity, okay, irrespective of its mass. So we simply mean that there's the acceleration of every object under the influence of gravity is constant. It doesn't matter what the mass is, whether it is heavy or light, okay? So that simply means that if we neglect air resistance, okay, if we should neglect air resistance of a body, a lightweight and heavyweight object, we have the same acceleration due to gravity. Consequently, if both of them are projected at the same height, if we project them at the same height, okay, we just place them at the same height, okay, um, and they are released, okay, they will reach the ground at the same time. So now let me illustrate. Let's say you actually bring a very heavy light object, very light object, okay, but not the one that's like paper that gravity that air resistance will influence. Then you now bring a heavy object. If you should leave this to project it and allow them to fall, okay, two of them will actually reach the ground at the same time. Why? Because in as much as gravity is concerned, acceleration, okay, under gravity is always what constant. And of course, according to him, after he has actually done his experiment, he actually the acceleration to gravity he actually denoted by the symbol G. Remember, in linear motion we have the acceleration we use A to represent, but now if we are dealing with acceleration due to gravity, we're going to use what symbol G to represent it. And of course, it's a constant for every object. Okay, so every object will always have a constant acceleration due to gravity, and that is approximately 10 meters per second square. All right, there are a series of experiments that actually led to this. It was Isaac Newton's experiment. Okay, so please take note of that. Now, how is this very useful to us, okay, in linear motion? Now this is useful because when the question involve motion under gravity, okay, we actually take note of the constant G. So how do we solve question, okay, of an object? How do you solve question that has to do with equation of an object? Okay, equation of motion of an object under gravity. So I'm gonna bring the next sub topic. Here we go. Okay, so I bring it up to the board. Okay, here we go. Now, equation of motion under gravity. Let me underline that. Okay, that's the topic we're working on. All right. Now, to solve questions that involve linear motion under the influence of gravity, we will always convert the equation we know, our linear equation, okay, into the equation under gravity because they are similar. The linear equation, okay, the linear equation, or the equation of linear motion is the same, okay, but with slight difference. As you can see, this is number one equation of motion under gravity. Is V equal to U plus or minus this plus or minus GT. Now, why the plus or minus? I'm gonna talk about that. But you discover that the only thing that happens here, this is the same equation I gave you previously. The only difference you see here, in place of A is being replaced by G. All right, and of course the distance we used to know, okay, the distance we used to we use S to represent, okay, excuse me. A is being represented by G. Then of course the distance X, which of course the linear distance, is being replaced by H, height, because we are dealing with height now. So that's why you see this. So V is equal to plus or minus GT. I'll talk about why the plus or minus. H is equal to UT plus or minus half GT square. Then number 3, V square is equal to U square plus or minus 2GH. The same, okay? G replaced by is replacing A, while H is replacing X. But why the plus or minus? Okay, so look at that. The reason why we have the plus or minus sign is that anytime an object is going upward, okay, is going against gravity. Gravity is downward. So if that is upward projection, we use minus, okay? So for upward, G is negative. So minus will take precedence. That's why you use minus, okay? Then for downward, okay, downward, that object is going for gravity because gravity is downward. G is positive. Excuse me. G is positive. So that is as simple as that. Can we now apply this, okay, to solve questions? Let's see. I think we can. I'm gonna get some question that we. All right. So, but before then, let's look at the hint. You need to just do some way of giving you hint that you need to actually consider before you solve question. Okay. Okay. Let me pick everything. Both the hint, the important hint, and of course, an example question. Okay. So, here we go. Okay. Put it on the board. Okay, important info you need to take cognizance of. It goes like this: when solving questions that involve motion under gravity, the following should be noted. At maximum height, if this object is going upwards, okay, there's a point where it will stop, it will start falling down. That's the maximum height. At that point, it doesn't have velocity. The final velocity at maximum height is equal to 0. So if you are dealing with upward movement at maximum height, final velocity is equal to 0. So please take note of that. If the object is projected downward from a height, let's say the object now is not, you're not turning it up, but rather you project it to release it to fall, okay? At that point where that object is being projected, okay, for it to fall, is at rest, the initial velocity is equal to what? 0 at the height of projection, okay? So please take note of that. There are other information we're still gonna find, but let's see an example. Okay, an object is projected vertically upward. As this object is going upward, okay? if it is thrown with a velocity of 20 meters per second, so this object is going upward. So remember what we do if you are solving question, we write our parameters down. Okay, write our parameter. So an object is projected vertically upward or going upward if it's thrown with a velocity. That means it's thrown with a velocity. The initial velocity is thrown with is 20 meters per second. You write it down. Okay. Now, remember, it's going upward at maximum height. Don't forget, upward movement will always get to a maximum height, okay? At the maximum height, the final velocity is equal to 0, all right? So the question is, evaluate the time it takes to reach the maximum height, all right, and the time of flight. Now, how do we evaluate that? V is equal to, so don't forget that G is a constant you can never miss out. Of course, the question will give you G. Under the question, okay? You will always be given G, which is 10 meters per second square. Okay. Then, of course, 10 meters per second square. Then, what do we have? We are looking for the maximum height. Okay, so the maximum height H is question mark. So I have now written down the parameters. So which equation carries these 4 parameters? And of course, you discover that the equation that carries these 4 parameters is the first equation, right? The first equation, V is equal to U, right? Plus or minus. Since it's an upward movement, I'm gonna take the minus, okay? Of course, GT. All right, so V is 0, U is 20, minus G is 10. All right, of course, T. So we have, take the minus 10T to the other side of the equation. It becomes 10T, of course, equal to 20. All right, and here we go. T is equal to 20 all over 10. All right, so the time for that object to reach the maximum height is 2 seconds. Okay, that's the first question. Now remember, we also asked to find the time of flight. Okay, time of flight is like the time of a complete total time for that journey to complete. Let's say you're going somewhere, you go and you return. Remember, the object goes up, okay, it returns back the same time. Okay, so that means the time of flight is going to be 2 times the time to reach the maximum height. All right, the time to reach the maximum height is 2 seconds. So the time of flight, we use capital 30 to represent it. Okay, it is always 2 times more than 30, the time to reach the maximum, because the object will go to and fro, come back. So that will be 2 times 2, which of course is 4 seconds. All right, so I hope that is well understood. All right, let's move forward. Okay. All right, let's get our note. The next, we see all of this. Let's see whether we have another question. Okay, to apply. Okay, here there's another question. I will bring it to the screen. Okay, here we go. Question number 2. A stone is projected vertically upward, the same upward projection, okay, with a speed of 30 meters per second. So solution, remember, we need to write down our parameters so that we'll be at a very safe side. Okay, vertically upward and the speed is 20 meters per second. And of course, you do well to write that the final velocity at that maximum height, because it definitely will get to maximum height, is equal to 0, comma, and you also do well to write the G down. Okay, All these are necessary so that you can easily pick a formula that you will use. Okay. Okay, so 30 meter from the top of a tower. Okay, 50-meter high. Wow, this kind of, there's some complexity here, but we will tackle it. Okay, so now please take note of this. Reading this question, I now discovered that this object was thrown not from the ground, okay, but from a top of a tower. That means the person that actually threw this object up is already at the top of the tower. Okay? And that top of the tower is 50 meter. This is where the guy is. It's 50 meters from the ground. So that means he didn't drop the object. He threw it up. Okay. So this object now, this is the height of the tower. Now move up before it actually comes right down. Okay. So which simply means that if I'm actually evaluating height using this particular formula, right? If I want to evaluate height, the height I'm going to evaluate is just this height from this point. Okay, this one, this is weird because this guy is from here, so this, let me call it small letter h. Okay, so now let's actually look at let's see what the question is actually. Neglecting a resistance, determine the maximum height it reaches from the ground. See what I'm talking about? So which simply means that the height we are measuring is from the ground. So, but the height we are going to calculate is the height from here. So, for you to get the height from the ground, first of all, you need to get the small h. Okay, so that means that height, let me call it capital letter H. Okay, it's going to be the small letter h we are going to find using this equation, right? Small letter h we find using that equation, then plus this 50 meter, the height of the tower. Okay, so let's get this height, question mark. So which equation actually gives me this height? Yeah, third equation will do. Right, v square is equal to u square, right? Upward movement, that is minus, right, 2 gh, right? Okay, so let's go there. So this is gonna be 0 square, please. 0 square equal to 30 square, right? All right, let's go there. Minus 2 times 10 times the h I'm looking for. So 30 square is no, is that is this is 0 already, right? So this is 900. Okay, 2 times this is 20. That's 20h. And if I rearrange this equation, bring this minus 20h to this side, becomes 20h, right? Of course, equal to 900. So I can easily get my h, which of course is 900 divided by 20. All right, if we do that, I think what I will have is, what is it, 45, right? Yes, 45 meter. Okay, so the h, remember, the h from that up there to the ground is actually small h plus 50, so that is going to be small h is 45, then plus 50. If you add that together, you will have 95 meter. Yep, as simple as that. Okay, let's proceed. Okay, if you just know how to apply this, you're just good to go. You're good to go. I got another question, and of course, that will do justice to it. Okay, okay, so let's move it. All right, I think I need to get it off. Okay, here we go. Okay, so it goes like this. Here, this question: a ball is projected from a height, so that this ball now is projected from a height of 20 meters if it is released. Okay, so that means the person that is actually releasing this voice from a height is Actually, the height is 20 meter. Okay, so this is where he's releasing the ball. All right. Okay. So now that's where he's releasing the ball from a height of 20 meter. Now let's write our parameters. Remember when I gave you hints. Okay, when an object is projected downward from the height at which it is being projected, the initial velocity is equal to 0. I've told you this already. Initial velocity is equal to 0. Okay, and let's proceed. H 20 meter. Don't forget your G is always constant. We will always introduce it in as much as motion under gravity is concerned. Okay, and we are looking for time for this object to reach the ground. So what equation do capture all these parameters? Of course, that should be a second equation. Okay, remember the second equation, H is equal to ut plus or minus. Now I'm using plus because it's downward, right? Plus half, all right, gt square. Here we go. H 20 meter, u 0. All right, t is what we are looking for, and plus half of g, which of course is 10, then times t square. So this is going to be equal to 20 equal to half of 5. Half of 10 is 5. That's 5t square. All right, so we have t square equal to 20 all over 5. T square is equal to 20 all over 5. That's 4. And of course, if I want to get t equal to t is going to be equal to, because this is t square, for me to get t, okay, so I'm going to have the square root of what? 4. T will be equal to 2 seconds. T is equal to 2 seconds. All right, so I hope that is well understood. Okay. Is there any other question we're gonna work on? Okay, so let's see if we could work on this. Right? All right. Here we go. All right, a body is projected vertical upward with a speed of 10 meters per second from a point 2 meters above the ground. Calculate the total time taken for the body to reach the ground. Okay, a body is projected vertical upward with a speed of 10 meters per second from a point 2 meters above the ground. The same thing that I illustrated the other time. Okay, so solution. So that means this body is projected at a height of 2 meters. Okay. So this height of 2 meters. Let's say this where the person threw the body. Okay, 2 meters. So a body is projected vertically upward with a speed of 10 meters per second, and as well, the speed of throwing is 10 meters per second from a point 2 meters above the ground. Calculate the total time taken for the body to reach the ground. Okay. So the total time is the time of flight. So the first time we're gonna look at is the time it takes for that body to actually reach this height. Okay, and the time it takes for from the body from this height to reach the ground. So first of all, let's evaluate the time it takes for the body to reach the maximum height. Okay, so here we go. So write down parameters. You know how we do that. Okay, write down parameters. So This is the initial speed of the object. Okay, u 10 meter per seconds. All right, so don't forget that maximum height v is equal to 0. And of course, g still return is constant, 10 meter per second square. Some question they'll give you 9.8. Please, whatever they give you as g, okay, use it. If they give you 9.8, use it. If they give you 10, okay, but if they don't give you, just use 10 approximately. All right, so here, so we are looking at the time. Let me use t1 for that, because there are two tm. The t I'm gonna look at, okay, let me use t1 for this, the time for it to reach this. Okay, so question mark 1 2 3 4 parameters. Which equation goes for us? Yeah, the first equation goes for us. All right, so we have v is equal to u. Upward movement, I'm using minus gt. So v equal to 0 and equal to u, which is 10. All right, minus g is 20. Okay, so rearranging my equation. Okay, you know how that works? Is equal to 10, of course. So my t is going to be equal to 10 all over 10. 10 all over 10, which of course is 1 second. Okay, here we go. So having done this, we will proceed. So t is equal to 1 second. Okay, so that's t1, right? Call that t1. Then this is the time. Let me illustrate that for this object to reach this point. Okay, so now we are going to look at the time for this object at this point to get to reach the ground. All right, so now there is something I need to find out. Okay, if I am not mistaken, right? Okay, yes. Let's look at the question again. A body is projected vertically upward with a speed of 10 meters per second from the point 2 meters above the and calculate the total time. Okay, so there's something I need to know the time for this object to move from here to this point. Okay, so there's something I need to calculate. This question is in different phases. I need to also to calculate this height, the height here. Let me use h. Okay, so that I can get the total height. Let's say, let me call it capital H. Capital H. Capital H is this small h, then plus this 2 meter, right? Okay, so let's get that height there. All right, so getting that height there, I'm gonna have this. Which equation am I gonna use? Okay, the same parameters. Okay, but this time around I'm looking for h. So that means invariably I'm going to use the second. That's h is equal to, right, 10 times t. All right, the t that average over, that's t 10 times 1, right? Remember, h is equal to, let me write the ut, right, minus half gt square. So h is going to be equal to 10 times t times 1 minus half, okay, times g, which of course is 10 times t square. Okay, that's 1 square. All right, proceed. h. Right, half of this 1 square is 1, half of 10 is 5. This 10, this is gonna be 10. All right, half of 10 is 5. 5 times 1 is 5. That's minus 5. So h h is equal to 5 meter. Okay, so that means this h is equal to 5 meters. So the capital letter H is going to be 5 plus 2. All right, capital letter H is 5 plus 2, which is what? 7 meter. All right, so having gotten the 7, that means all the way from here to here 7 meter. All right, so now let's say this object is not thrown from the height of 7 meter down. Okay, we are looking at the time from this. We already calculated the time, which I call T1, for it to move to this point. For this point, it actually fall all the way down from a height of 7 meter. Okay, so remember, from the point of projection, remember it now becomes downward projection. Okay, so if you want to write the parameter at that point, now u is equal to 0. Remember that. Okay, downward projection, and of course the h I'm going to be using is this capital letter H, which of course is 7 meter, right? G still remain what it is. Okay, then of course I'm looking at that time now. That time I call it T2 question mark. Okay, so let's apply. That should still be my second equation, right? So second equation, H, right, which of course is ut downward now, that's plus half gt square. Alright, this is kind of long. So H is gonna be equal to u0. U is 0, right? Of course, times t. That's still give me 0. Or then plus half g, which of course is 10. Alright, then t square. That h is 7, so I can just write the 7 at once. Okay, that h is 7. Right, so rearranging this equation, half of 10 is 5. So I'm gonna have okay. So I'm gonna have 5t square, right? 5t square equal to 7. So equal to 7, right? So t square is going to be equal to 7 all over 5. All right. Okay. Of course, calculator will help us here. Calculator will definitely help us. So let's get a calculator. All right. So there you go. So 7 all over 5, of course, we need to find the square root, okay? 7 divided by 5. 1.4, okay? There's 1.4. Then, so t now becomes the square root of 1.4. Okay, here we go. Square root of 1.4. That's 1.1. That's 1.2 approximately. Okay. Am I mistaken? Yeah, 1.2. So t is 1.2 approximately. Okay, so that's t2. Remember t2. So my total time of flight now. Okay, capital letter T is gonna be equal to what I had in T1 plus this T2 now at the bottom, which of course is gonna be what I have in T1 was 1 plus T2 1.2. Okay, so everything gives me 2.2 seconds. Okay, so I hope that is well understood. All right, so we're going to look at more example, more questions, then we'll also proceed with other sub topics. Okay, we'll definitely in this tutorial we're still going to look at projector. Yeah, we'll look at projector. I think that's what is actually left here. All right, see you in the next video. Thank you very much.